Alright, we got another weird one in the shop today. 2004 Duramax HD 2500 pickup. And we got heater blower control only working in the high speed. Does not work in any other speeds. When you go to off, it does move HVAC controls. The weird thing is, when you go to high speed, it messes with the ABS light. So, if we go down here and disconnect the fan, and we're in any speed 1, 2, 3, 4, you can hear the ABS pump cycling like on a startup, like you'd initially be turning the key on. I don't know if you can hear that. Anyway, it does a short cycle like when the ABS does its motor test. So that's when you disconnect the blower motor. So we have some electrical continuity through the switch, through the blower resistor. A friend of mine owns the truck. He replaced the blower resistor. He replaced the blower motor. He also subbed out the HVAC control and got the same results. So I disconnected the fan and put a light bulb in place of the fan motor. And on high speed, we get full brilliance of the light bulb. But when we leave position 4 and go to speed 5, we get the ABS pump motor cycling again. And some occasional blinking of the ABS and brake lights on the dash. So if I turn the light off and we're on position 4, you can just barely see some glowing of the light bulb, but not very much. When the truck is in speed 5, we are using a relay inside the blower motor resistor. Speed 5 jumps the relay to the red connection, giving a full 12 volts to the blower motor, going back to blower fuse 40 amp in the engine compartment. So we have good power there. That's working fine. Otherwise, all other speeds are passed through the resistor banks to create different speeds of the blower motor. That all goes back to the switch on the dash, the blower motor switch. That receives power through the brown wire, 30 amp heater AC fuse in the left side of the interior compartment, the triangular shaped fuse cover. So on the small fuse panel inside the engine, or inside the cabin compartment, we're looking for a 30 amp fuse, heater AC. That fuse powers the blower motor speed switch, independent of high speed, of the highest blower speed. So right there, if we probe that, only getting 9 volts. If I energize the power probe, get a full 12 like we should. And that's right off the battery, of course. So this is a little unusual. We're low on voltage, which would explain why we don't have enough voltage to operate the blower motor on speeds 1 through 4. Alright, I got this fan speed setting on 4. Plug the fan motor back in. And so we've got a load on there. Let's see how much power we have the fuse now. 0.1. So with a load, we dropped to nothing. So let's energize it. Alright, so we got... sounds like we got the blower working. So we are somehow missing power to that fuse, which should be coming from hot and run. So we're losing power at the ignition switch or somewhere before. Alright, so if we're looking at the diagram, here's our HVAC control module, manual AC, brown wire, heater AC fuse, 30 amps. And this is all in the left instrument panel fuse block, lower left side of dash. So power is coming to that fuse, and we have low power there. And that is fed by the orange wire coming from the run position of the ignition switch. So we need to figure out why we have low power at that point. If it stops at the ignition switch, I believe he said he replaced the ignition switch, but new parts are pretty hit or miss these days. So we're going to check that out next and see if the power coming into the fuse is also low. If it's not, then we know we're losing power at the run position, orange wire, at the switch. That might make sense when you cycle a load on the blower motor switch. It's also causing other circuits to malfunction, which would make sense that the ABS is resetting like it thinks it's getting a big initial ignition switch on. So we'll check that out next. Alright, so here's our 30 amp heater AC fuse that controls the blower motor speed switch at the HVAC control module. And we have low voltage there, and if I give that fuse power with the power probe, the blower motor works. So that circuit is paralleled and feeding several other things. Ignition 3, cruise, that's HVAC, the 10 amp for I think auto. It looks like it feeds some other things, circulator, actuator rather. That circuit also powers the brake fuse off the ignition switch electronic brake control module. That would explain why when we put a load on it, it's taking the voltage away, what little voltage there is, and then causing the brakes to cycle every time. it thinks the ignition switch is being turned on and off. So if we go back here to the feed to all of that is an orange wire coming from the ignition switch run position, and that is fed from ignition A fuse, diagram 1 of 5. We'll go back to that. I'll wait for this old computer to load. Ignition A fuse. This is the very first diagram, breaking out everything from the battery. So you need ignition, not so easy to find, but it's got to be there somewhere. Ignition A fuse, 40 amps, red, to ignition switch, diagram 4 or 5, that's where we were. Starter relay, so ignition A fuse, should make sure that has power, and that is likely in the fuse block, in the fuse panel underneath the hood. So if we go back here, everything is still on. We still only have 1/10 of a volt at our heater AC, so we'll go to the ignition fuse A. Should be one of these large ones. Ignition A, 40 amp. Third one over from the bottom. Looks good, but not really going to be easy to load test anything from here. Pull it out. And I have 12 volts on one side, which is probably the right side. Nothing on the other. If we energize the other, not really able to tell if the blower is working or not. We'll see if it'll turn on, if I can hear it. Does not appear to be making the blower work. All right, we'll check, do some more checking with the diagram. All right, so if we go back to the ignition switch, fuse A, fuse was good, checked good. Introducing power there with the fuse removed didn't change anything, which is fine. So that red wire goes along this bus bar in the ignition switch, feeds the run, start while cranking. So orange wire is not getting power. Yellow and white will check. So we'll get some light here. I took all the plastic off already. We're at the ignition switch on the bottom of the steering column. There's our red wire. We have power there. There's another red wire behind it. No, that one has a tracer. That has power. That one has power. That, I can't tell, kind of looks orange. This is a yellow, has power. This one has no power. That's crank. So we have power coming into the fuse, or into the ignition switch. Here's our orange with no power. If I energize that with a power probe, we get our blower back. As far as I can tell, that's a bad ignition switch. And I believe he just replaced it. So, let me just remove that plug and check continuity between each terminal to confirm. But basically, red is power going in from the ignition switch fuse A under the hood, going through the ignition switch, feeding these other various circuits, the yellow and a white, which I think is what that one is behind there. Yeah, that's got voltage. It's white. It looks like a white tracer. Now there's what appears to be a black wire behind there. It could be brown. That also has voltage. But no voltage where we need it. So we energize it. I'm going to say this is a bad ignition switch, but we'll double check and confirm. Alright, so I got the ignition switch out. It's brand new. He just bought it. He just installed it. If you look down in there, you can see letters A, B, C, D, E, F, G. According to the diagram, we should have power coming in into F. That's the bus bar inside the switch. And it should go to G. In the run position, we should have continuity. So from F to G, that's the last two. It's going to be slightly difficult to do one-handed. Okay, we have no continuity on this meter. We'll go to the first position. There's run. There's crank, so it's off again. Run, 85 ohms. That's not going to work. We can test other functions of the switch. We'll take our power from F and go to D and start. So there's D. F. We should have continuity in crank. Start. Like an ohm or two. Yeah, 0.1. Perfect. And it does crank over, so we know that function works. We could do one last check from F to E, which is your accessories, and ignition run are all on while cranking. So we'll go E to F. Those are right next to each other. We have continuity there in run and crank and accessory. Off, we have nothing. So that's correct. So this brand new ignition switch is bad. 85 ohms continuity between F and G isn't going to cut it. So internally there's something wrong with it. So we'll get a new ignition switch, another new one, and try it again, see what happens. Alright, wanted to make a final video to let you know that everything was repaired. I replaced the ignition switch with a new one, and our cycling ABS brake light's gone away, and we now have all the fan speeds back. So everything was the result of a bad ignition switch. And the customer picked up a new one. So that seems to have repaired everything. Another new switch, identical, same box, bought a couple of weeks later, but it seems to work for now. So hope this helps someone out who's chasing down some weird, strange electrical issues.